Okay, so here we go. So when we're solving trigonometric equations, let's take a look at this graph, right? Imagine you need to solve, oops, there's the new one. So imagine you need to solve that equation, cosine of x is equal to a half. Here we go. Okay, cosine of x is equal to a half, right? Now, with solving any equation, right? Like suppose you have an equation like y equals 3x minus 2. Okay, and you need to solve this equation. Okay, or let's say you want to solve 3x minus 2 is equal to 5, right? For what x value is it equal to 5? What you can do is you can graph 3x minus 2, okay? And it kind of looks like this. And then you can see for what value of x is this equal to 5? And that value of x is your solution, right? Now, when you have something like cosine of x is equal to a half, what we do is, this is the blue one, y equals cosine of x. And then the red one is y equals a half, right? So now we can see where the points of intersection are, and those are the solutions. So you can see there is a solution right here at x equals pi over 3. But that's not the only place that they intersect, right? Because if you go over by 2 pi, right? Pi over 3 plus 2 pi is another place where you have a solution. Or pi over 3 minus 2 pi is another place where you have a solution. Similarly, you also have a solution at another point. 5 pi over 3 is another place where you have a solution, but also 5 pi over 3 plus 2 pi, 5 pi over 3 minus 2 pi, and so on, right? So you have like multiple solutions, okay? All right, so that means on the interval 0 to 2 pi, your solutions are pi over 3 and 5 pi over 3. But over all of the real numbers, your solutions are pi over 3 plus 2n pi. Because you can take the pi over 3 and you can add 2 pi, then you can add another 2 pi, you can add another 2 pi, you can add n number of 2 pi's, right? So that will be the general solution, or 5 pi over 3 plus 2n pi. Okay? All right.
Plus or minus or not?
No, just plus, because n can be positive or negative integer. Any integer. Okay? All right. So now let's take a look at this one first. So 4 sine x equals 2 sine x plus root 2. We want to solve this. What you want to do first is we want to isolate the trig function, right? Now, look at what this says. This says solve the equations over the interval of real numbers, right? Okay. So here we subtract 2 sine x. So I get 2 sine x is equal to root 2. Then divide by 2. So sine x is equal to root 2. And then we have to figure out where this happens. So on the, where? Right. So where does that happen? At pi over 4, sine is root 2 over 2, and where else? 3 pi over 4. Okay, remember, so first you go like one round from 0 to 2 pi. However, I want this over the interval of all real numbers. So I take the first one and I say pi over 4 plus 2 pi n. And then I take the second one and I say 3 pi over 4 plus 2 pi n. And these are my x values, right? So that would be your solution. Okay, yeah.
Was it like only for one of them the value could be from 0 to pi, and the other two it was from here to here, like?
No, those are inverse sine. That's a completely different thing. Yeah, this is just sine of x. That's inverse sine. So that doesn't work here. Those were for the inverse sine functions. This is just regular sine. Yeah.
Wait, can you remind me why you put the 2 pi over n for this?
Oh, it's 2 pi n. Okay. Okay. Okay, so let's take a look at this one. Subtract 4. So I have 3 cotangent squared x is equal to 3. And then divide by 3, so cotangent squared x is equal to 1. And then I need to take a square root of both sides. So I get cotangent x equals plus or minus 1. Now, this gives me two equations. Cotangent x equals -1. Cotangent x equals +1. Okay, so let's see. Cotangent x is equal to -1 here and here, right? At 3 pi over 4 and at 7 pi over 4, because that's where cotangent is negative, okay? Now, cotangent is +1 at pi over 4 and 5 pi over 4, right? No, that's sine and cosine, but cotangent is 1 there. Okay, now, I need to write the general form of this. Okay. So take a look at this one. Instead of saying pi over 4 plus 2 pi n, 3 pi over 4 plus 2 pi n, and so on, the point is, okay, what you want to create when you do this is if you're on one solution, how can you go back to the next solution, right? And then if you're on another solution, how can you go to the next one? How can you go to the next one? Okay, so take a look at this. There is a special situation that's happening here. Look at these blue ones. They're 180 degrees apart, or pi units apart. So actually, to go from one blue to the other blue, I don't go over 2 pi. I only have to go over pi. Okay? And then same thing with this. The red ones, they're on one line. They're not 180 degrees apart, right? So to go from one red one to another red one, I only go plus pi, plus pi, plus pi, plus pi. However, in the middle of these two is a 90-degree angle. So now if I zoom out and I look at all of the solutions, to go from one solution to the other solution, it's 90 degrees. Then to go to the third one, it's another 90 degrees, another 90 degrees. So when you have a pattern like this, what you do is you take the first one and you say plus pi over 2n. Okay? So if they're on a 180-degree line, you go from one angle plus pi n, and then if they're, if they're like the four corners, then you would do pi over 2n. Yeah.
So on the first one, why didn't you just do plus pi?
Because those are not, because look, from the first one to this, from one solution to the next solution, right? Okay, so from here to here, it's 90 degrees, right? From the first one to the second one, it's 90 degrees. But then to go from here to the next one, it's not 90. Like they're not at regular intervals, right? So here is the first answer, then the second answer, then the third one is here again, right? To go from 1 to 2 to 3 to 4 to 5 to 6, you're not going at regular intervals. You would only do it if you're going perpetually at regular intervals. Okay? All right. Yeah.
Did you say that you go by like the smallest possible interval?
I guess, but they have to be even, right? Yeah, I get. I mean, yeah. You'll see it. You'll see it and you'll know. Okay? All right. So take a look at this one. Now it says to find the solution over the interval 0 to 2 pi. When it says over the interval 0 to 2 pi, we're going to leave out the plus 2 pi n or the plus pi n or the whatever. Okay? So here, tangent of an angle is equal to √3. Now in here, the trig function is already isolated, right? The angle is different, but the trig function is isolated. So you ask yourself, okay, where is tangent equal to root 3? Tangent is equal to root 3 for what? Here? Pi over 3. And then where else? 4 pi over 3. Right? Okay. So now,
Is it always 1 pi apart?
are those 1 pi apart? Yes. Okay, it's not always going to be like that. So you just have to take it as it comes, right? So now, but however, hang on, stop. We don't care about that for this one because it's only from 0 to 2 pi. So we only have to take one of them, okay? So now we say tangent is equal to root 3 when the angle is equal to pi over 3. In this case, what's the angle? Theta over 2 is pi over 3. And then theta over 2 is 4 pi over 3. Okay? So just like here, we said x is equal to 1, and then, okay. You do. Now, to find theta by itself, I multiply by 2. And here too, I multiply by 2. So theta is equal to 2 pi over 3. Theta is equal to 8 pi over 3. Let me just solve for theta, so multiply by 2, okay? 8 pi over 3 and 2 pi over 3. Okay, let's do another one. Cosine of 2 theta is equal to negative a half. Okay, so let's see. Cosine is equal to negative a half here, 2 pi over 3, and here, 4 pi over 3. Is that right?
Yes.
So that's where cosine is equal to negative a half. So we say cosine is equal to negative a half when the angle is 2 pi over 3, and then when the angle is 4 pi over 3. Okay? So now I need to divide by 2, right? Let me go with a different color. I need to divide by 2, which is like multiplying by 1 over 2. So I get theta equals pi over 3. Theta equals 2 pi over 3. So those are the two answers. And the reason why that happens is because when I change from theta to 2 theta, remember, like what happens? So if this is cosine of theta, that is sine of theta. Okay, sine of 2 theta, what is that like? This, right? Do you see how much it's faster? So it hits the points in like double the time. That's why you're going to have different answers. Okay? Okay. So now, okay, let's take a look at this one. Now it says solve each equation, give a general formula, and list 6 solutions, right? General formula and 6 solutions. So let's do this. Okay. Sine of 3 theta is negative root 3 over 2. I wasn't thinking when I was doing this, and they mostly all came out to the pi over 3s, but they're not always going to be the pi over 3s. Okay, so when is sine equal to negative root 3 over 2?
4 pi.
At 4 pi over 3 and 5 pi over 3. Okay, so I say the angle is equal to 4 pi over 3, and then the angle is equal to 5 pi over 3. But I need the general formula, right? So over all of the real numbers. So it's 4 pi over 3 plus 2 pi n, 5 pi over 3 plus 2 pi n. Because it says the general formula. It's not from 0 to 2 pi. It's everything. So now, when I divide by 3, I need to divide everything by 3. Okay? So what do I get here? Theta is equal to 4 pi over 9 plus 2 pi over 3, n. Theta is equal to 5 pi over 9 plus 2 pi over 3, n. So these are the general formulas.
Is the n not part of the 3?
It doesn't matter. It's like you can put it
Okay.
anywhere. Okay. Right now it says to give 6 solutions. Okay, if you have 2 equations, you could just do 3 and 3. So what we're gonna do is this. We're gonna say, okay, n equals 0, n equals 1, n equals 2. Okay, for both of these. Okay, so when n equals 0, it's 4, theta equals 4 pi over 9 plus 0. Okay, here, when n equals 1, theta equals 4 pi over 9 plus 2 pi over 3. Right, so how much is that? 4 pi over 3, how much? 10 pi over 9. And then here, 4 pi over 9 plus, this time n equals 2, so 4 pi over 3, 16 pi over 9. Okay? So these are 3 of your 6 answers now. And then, let's just do 3 from the other one. So theta equals 5 pi over 9 plus 0. Theta equals 5 pi over 9 plus 2 pi over 3. So that's 11 pi over 9. And then theta equals 5 pi over 9 plus 4 pi over 3. How much is that? 17 pi over 9. Okay? So those are the other 3. So those are 6 solutions. Okay? Okay. Huh? I mean, you can, but it doesn't specify. So I just do 0, 1, 2. I just choose them. Okay. Okay, take a look at this one. So where is tangent equal to -1? And 7 pi over 4. So I say theta over 2. Okay, let me draw that. So here, right? Here and here, 3 pi over 4 and 7 pi over 4. So theta over 2 is equal to, so 3 pi over 4 and 7 pi over 4. But do you see how those are on a 180-degree line? So I'm just going to do the first one plus pi n. Okay? So then when I multiply everything by 2, I get theta is equal to 3 pi over 2 plus 2 pi n. Yeah.
Is that a tangent thing? Because all the tangent graphs have that.
Well, yeah, it'll happen a lot for the tangents, not for the other one, but it can also happen for some of the other ones. Okay. All right. So now, okay, so here we go. Let's find 6 of them. So when n equals 0, theta equals 3 pi over 2. N equals 1. Theta equals 3 pi over 2 plus 2 pi n. How much? 7 pi over 2. Well, if they're random ones, you do each one plus 2 pi n. But if your angles are on a 180-degree line, then you just do the first one plus pi n. Okay, so then this is going to be plus 4 pi n. And how much is that? 11 pi over 2? No. This is 11 pi over 2, right? N is like, it's like when you do plus 2 pi n, it means you can add 2 pi once or twice or 3 times or 4 times. So that's, yeah, we're just, yeah. And then, so you're going to continue n equals 3, n equals 4, n equals 5. I'm not going to do that. You guys know how to do that. Yeah. Not, because I'm just training you guys. I'm just training you. Yeah, no. I'm just training you because like to know what that plus 2 pi n does, you know? Yeah. Okay. So let's move on to this. Find the solution of the equations over the interval 0 to 2 pi. So now we don't have to do the pi n's anymore. Okay. Here. What do you think we should do? Okay. Every time students, every year, I expect students to say divide by sine x, which is, it seems like the most rational thing to do. However, do not do that. What we're going to do instead, whenever we have these equations where you have multiple ones, is bring everything to the same side. When you have multiple trig functions, everything to the same side and set it equal to 0. So this one, let's bring this to this side. 2 sine x cosine x minus root 3 sine x is equal to 0. Now, question. How many terms are on the left side of this? Okay, so if each term is always separated by a plus or a minus, there are 2 terms, right? There are 2 terms. Is there a common function in the 2 terms? So we're going to factor out a sine x. Okay, if I factor out a sine x here, I get 2 cosine x minus root 3 equal to 0. Now that I have one thing times another thing equal to 0, I can now set each one of these equal to 0 on its own. Oops. Okay, so sine of x is 0 at 0 and pi, right? Here and here. And then 2 cosine x equals root 3. Cosine x equals root 3 over 2. And that happens here and here. So x is pi over 6 and 11 pi over 6. So now, if initially you had divided both sides by sine of x, you would still have gotten the pi over 6's, but you would not have gotten the 0 and the pi as a solution, right? So you would only have gotten half of your answers. Okay, now, convention is to write your solutions from from in like increasing order. Will I take points off? I mean, no, but because we're becoming elegant math students, why don't we just do that? Okay? All right, let's do another one. I'll take questions after the next one. Okay. Look at this one. What do you suggest we do? Right. 4 cosine squared x plus 2 cosine x minus 2 root 2 cosine x minus root 2 equal to 0. Always bring everything to the same side, set it equal to 0. Now, next, you're going to think of factoring. That's what we did here. Same side, factor, solve. Okay, here, Okay, how many terms are in this one? 4. When you have 4 terms and you want to factor by grouping. Always try out factor by grouping. So split it down the middle. And then from this side, I can factor out 2 cosine x. So I get 2 cosine x plus 1. Here, what do you suggest I factor out? How about negative root 2? So then I get 2 cosine x plus 1. Oh my God, I get the same term. Do you see that? Do you see how this and this are the same? So now you can factor that out. Essentially what that's like is write down the common term and then in another parenthesis collect what's left over. 2 cosine x minus root 2 is equal to 0. Okay, now look. Let's compare this step and this step. And let's look at how they're similar and how they follow the rule. In both cases, you have one thing times another thing equal to what? 0. One thing times another thing equal to 0. This is the only way you can set them each equal to 0. This is called the zero product property. It's not the 4 product property. Like if it was one thing times another thing equals 1, you couldn't solve it like this. Okay? So now 2 cosine x plus 1 equal to 0. 2 cosine x equals negative 1. Cosine x equals negative a half. And then where? Where does that happen? And, okay, 2 pi over 3, 4 pi over 3. Okay, so now you see how you just, like, for the last test, you just had to know, like, sine of 2 pi over 3, cosine of 4 pi over 3, right? Because now you need to know them backwards. Okay, here, 2 cosine x equals root 2. Cosine x equals root 2 over 2. When is that? Pi over 4 and 7 pi over 4. Okay? So in order, they would be pi over 4, 2 pi over 3, 4 pi over 3, 7 pi over 4. Okay, questions? Yeah.
There's probably won't get a problem like these that we also have to like find the 6 solutions, but it's not everything, right? Like
No.
These are all over 0 and 2 pi.
Right, right. Yeah, if it says 0 to 2 pi, this is it. But I can ask you to solve this exact same equation with that. Yeah. Okay. Okay. Now, these are the easy ones, right? Do you remember? Okay, we learned about trig identities. And then in the last lesson, we had to substitute trig identities to simplify things. Now, we're going to combine last lesson with this lesson. So let's do that. Okay. Look at this one. Find the solutions from 0 to 2 pi. So here, we're going to use trigonometric identities to solve these. Okay, take a look at this situation. The problem here is, even if I moved everything to the same side, let's do that now, I can't solve this in any method as we did before. Like, I can't factor out a sine x. I can't factor out a cosine x. So now I need an identity. Now, I have here cosine and sine. I need to replace one of them with the other one. The best thing to replace is the identity, the trig function that's squared, because we have the squares, right? So look at this one. Sine squared x plus cosine squared x is equal to 1, right? Now, I want to get rid of the sine squared x. So here, let me solve this for sine squared x. When I subtract the cosine, sine squared x is 1 minus cosine squared x. So now let's substitute. Right? So far it's the same. And then just for this, I substitute 1 minus cosine squared x, and that's equal to 0. Right? This is exactly what you were doing in the last lesson. Now let's solve. So let me distribute. 1 minus cosine x minus 2 plus 2 cosine squared x is equal to 0. Now, 1 minus 2 is negative 1. No. 1 minus 2 is that. So let's just write this in standard form. So the 1 minus the 2, right, is negative. So this is 2 cosine squared x. I'm just rewriting it in better order. Okay? Okay, now I need to solve, now I need to factor this. Look at this. Do you see how this is this is a quadratic equation? 2x squared minus x minus 1, right? If you had 2x squared minus x minus 1 equal to 0, what would you do? How would you factor it? Right, you would do this. 2x, x, 1, 1, right? Plus minus. Did we do this last year? Yeah, we did. Okay. No, I mean like with the cosines. I don't remember. Yeah, okay. Oh yeah, that's right. We did, and you guys did really well. You guys did surprisingly well. I was actually not surprisingly. No, because usually in algebra 2 students struggle with it, but last year I was like amazed at how well you guys did. So yeah, okay, yeah. Kudos to you for sure. Yep, especially you, just you. Okay, So here, instead of the x now, we have cosine. So we're going to do 2 cosine x, and then we're going to get a 1, right? So that's going to be either plus 1 or minus 1. So let's do this. Now look, this has to like foil to the middle. So basically, look, if you do the outer negative 2 cosine x, and then the inner positive cosine x, it should add to negative cosine x, which it does. So this is the right factoring. So now, let's solve this. 2 cosine x plus 1 equal to 0. Cosine x minus 1 equal to 0. So this one, cosine x is equal to negative a half. And here, cosine x is equal to 1. Yeah. Okay, so where is cosine x equal to negative a half? Other one. So that's here. We want cosine to be negative a half. So right here, 2 pi over 3. And this one, 4 pi over 3. Where's cosine x equal to 1? 0. Okay, so my answers are 0, 2 pi over 3, 4 pi over 3. Huh? What one? Cosine is 1.
Oh, -1,
Right, that's negative 1. Yep.
I might be completely wrong, but like in the beginning of the equation,
Mm-hmm.
you also do it's like 1 minus cosine x. Isn't that also just sine or sine
No,
x?
because it's not squared. 1 minus cosine squared x.
But if it was
Yeah, if it was cosine squared, yeah, then that would be way too easy and boring. Yeah.
so the identities don't work in square.
No, yeah, correct. They have to come to you squared. Okay, what do you suggest we do here? Right. It is 4 terms. So how do you suggest we factor? Yes. Okay, I'm factoring out a cosecant squared x. Oh. What can I factor out here? Nothing really, just minus 1. Okay, so I'm factoring out a cosecant squared x, right? Which means from here, I take out the cosecant squared x, I have cotangent squared. And then from here, I have 2 left because I took out the cosecant squared.
Why would you take out a cosecant if you have cotangent?
Yeah, we don't really.
No, you take out the thing that you like both terms have in common. Yeah. Yep. Oh yeah, plus 2. Sorry, I was trying to listen to a question. I mean, try it. If it doesn't work out, then you have to come up with like another. Right, or if it doesn't work out, then you have to do some sort of trig identity and substitute. Okay? All right. So here, let's write down the common term. and then collect what we haven't used. Okay, so now, here, cotangent squared x plus 2 equals 0. Cotangent squared x equals negative 2. Take a square root. Does that work? No. So this part gives you no solution. Now let's take a look at the other part. Cosecant squared x minus 1 equals 0. Cosecant squared x equals 1. Take a square root. Cosecant x is plus or minus 1. Okay, cosecant is like sine, right? It's 1 here and negative 1 here. So those are your only answers. And if we were solving this over the entire domain, like if this was, right? What would you have written? Pi over 2 plus pi n. Okay. Okay, let's do these two as well. Oh my God, these are like my favorite ones here. These two. Because look at this one. There's nothing you can do here, right? You can't factor anything out. You can't divide anything out. You can't even substitute an identity because nothing is squared. Like I have identities with tangents and secants, but they're squared. But this isn't squared. So what do? No, we can do something.
Oh, we put them in their regular form. Yeah. Regular form. Sine over cosine.
How about square both sides? Look at that. Square both sides. Now, this one though, when you square it, remember, you square the first term, you square the last term, and then inside you have secant times 1 times 2. 2 secant of x. You don't get secant squared plus 1, okay? Equals tangent squared x. Okay, now I can use an identity, right? So look, when you go over here, I have a tangent squared identity that I can use, this one, right? So tangent squared plus 1 is secant squared theta minus 1. Or tangent squared is secant squared theta minus 1. So here, oh my gosh, it's way down here. So this is going to equal to secant squared x minus 1. Yeah. Now, oh my God, it all of a sudden transforms, right? Because, look, secant squared x, you can subtract them, they go away. Minus 1, I have 2 secant x equal to negative 2. Secant x equal to negative 1. Where is secant x equal to negative 1? Pi. Okay, but because we had to square both sides, you can't just now accept it as is. You can possibly have introduced extraneous solutions. So for the ones where you have to square both sides, you have to check before you move on. You have to check. 9 times out of 10, only half of your answers will work. Okay? Okay. So, where do you plug it in to check? Anywhere before you squared. So, let's go here. So, secant of x plus 1 equal to tangent x. So, let's check. Is secant of pi plus 1 equal to tangent of pi? Tangent at pi is 0. Secant at pi is negative 1 plus 1. Oh my God, that does equal 0. So yes, that is a solution. Okay? All right, we're going to stop here. I'm going to give you your worksheet to do.
If it doesn't work, there's no solution.
If it doesn't work, there's no solution. You take the ones that work. Now look, for your worksheet, you're going to do everything except for 12, and 13. So for the homework, it's a worksheet. It's 5.3 worksheet, and you're going to do numbers 1 through 11. Listen, you have to use your calculator for some of them. There are some word problems for which you're going to rely on knowledge from from chapter 4 and how we solve those same methods here. Okay? All right. Huh?